As we start to shift to solving quadratics, we have to look at solving by square roots. So in the past, whenever you've simplified expressions, you've used order of operations, parentheses, exponents, multiplication, division, and then addition, subtraction. In order for solving, we reverse that process and do addition, subtraction first, multiplication, division, exponents, and last parentheses. Now, it may seem a little odd that we're doing this order, but we have to remember our goal here is to isolate whatever's squared, take the square root of both sides, and then solve. And we're going to see that on some basic examples and then build up to equations we're going to solve. So first up, I have x squared equals 1. Now, when we take the square root of both sides, we might think square root of x squared becomes x, and the square root of 1 just becomes 1. But that is not necessarily true, because if I reverse that order, what could I square to get a positive 1? The negative value would also work. So what we do, anytime we take the square root of both sides, we write plus or minus on the side with the number. So it's going to be plus or minus the square root of 1, so plus or minus 1 is our two solutions. Now we can just write the plus or minus there, or you could write x equals positive 1, comma, negative 1, listing out your solutions that way. So x squared equals 4. I take the square root of both sides. That becomes x equals plus or minus the square root of 4. So x equals plus or minus 2. Now what if we said x squared equals 0? If I take the square root of both sides, the square root of 0 is not going to be a plus or minus. That one just comes out to be x equals 0. Now what if I have something inside the parentheses? I've reached this point where I have x minus 2 inside a parentheses, and I can't move the 2 out. So I'm still going to follow the same process and take the square root of both sides. But now it becomes x minus 2 equals plus or minus the square root of 9, or x minus 2 equals plus or minus 3. The last thing I'm going to do is move the 2 over, so that becomes 2 plus or minus 3, which is actually two solutions, 2 plus 3 and 2 minus 3, which is 5 and negative 1, so our answers are 5 and negative 1. Now when it's a plus or minus and it's a numerical value, you need to simplify out to find the two solutions, in this case 5 and negative 1. Now x squared plus 4 equals 0. I'm going to get the x squared, like I said, by myself. That's the big goal here. So subtracting 4 over to the other side, I'm now taking the square root of both sides, and I get the square root of negative 4. And this should be a problem because we've always kind of seen before we can't take the square root of a negative because you can't square a value and get a negative number. 2 wouldn't work, negative 2 wouldn't work, you're kind of stuck here. This is where we say for now, no real solutions. And what we'll see later on is we can actually take the square root of a negative, it just gives us what we call an imaginary solution, because if it's not real, it's imaginary. Not so much we have to worry about right now, but something to look out for. Now, last note I have here down here is eventually we'll have to simplify radicals in these problems, just not yet. Our bigger goal right now is to be able to solve the equations. So, a couple others. I have 0 equals 4x squared minus 100. I want to get the x squared by itself, so I'm going to undo order of operations. I'm going to add 100 to the other side, or to both sides. That moves the 100 over. I get 100 equals 4x squared. I now divide both sides by 4. 25 equals x squared. So now once I take the square root, it becomes plus or minus the square root of 25. So x equals plus or minus 5. Now, what do these solutions mean? If we took this equation we started with and wrote it as y equals 4x squared minus 100, first of all, these solutions are when we make y 0, what the equation would be. And keep in mind, when y is 0, that is the x-intercepts. So this means if I sketched this graph at negative 5 and positive 5, the parabola would go through 0. Now let's think of the other things we know. If it's 4x squared minus 100, it is opening up and it's very steep. So I could get an idea. The graph looks like that. It opens up, it goes through those points. It probably has an axis of symmetry on the y-axis because it's symmetrical to where we're at. The vertex by vertex form would actually be 0, negative 100, and we can kind of see what the parabola looks like. And really these solutions help us because it gives us a quick understanding of what this parabola may look like and how it behaves at the x-axis. On to our next one. x plus 3 inside the quantity squared minus 4. I want to get the squared quantity by itself, so I'm going to add 4 to the other side, to both sides to move it over. And so now we have 4 on the right side. When I take the square root of both sides, it leaves me with plus or minus the square root of 4, which becomes x plus 3 equals plus or minus 2. We subtract 3, and we get negative 3 plus or minus 2. So we write our two values, negative 3 plus 2 and negative 3 minus 2, gives us that x is negative 1 and negative 5. Alright, our word problem here, an arrow is shot vertically at the height of h, and after t seconds it's given by our function. When does it hit the ground? So we take this function, we put 0 in for h, which gives us the equation we can solve for it. And so anytime we take that function with y, f of x, or h in this case, and put a 0 on the left side, it makes it a way that we can solve and find the solutions. Because remember, it is when y is 0, or the y value is 0. Now let's kind of look over at the graph and picture it and see if we can kind of cheat to get an idea. Now the negative 16 out in front tells us it does open down, which is why I've sketched it like this. The vertex, if we use our vertex form, is 264. Now we take the assumption that it started with a height of 0, went up to its maximum, and came back down. And we could kind of start to guess to what it looks like, but let's go in and solve and see what works for us. So first thing I want to do is subtract the 64 from both sides. So we have negative 64 equals negative 16 t minus 2 squared. We then divide both sides by negative 16 and get a 4 equals t minus 2 squared. We take square root of both sides, and we have t minus 2 on the right, plus or minus the square root of 4. T minus 2 still on the right, with a plus or minus 2. So now, move over here, we're going to add 2 to both sides. We get 2 plus or minus 2. So our answers are 2 plus 2, and 2 minus 2, 4, and 0. Now, the 0 is the initial. That really doesn't mean anything to us. What we're looking for is when, or after how many seconds, does it hit the ground, and that is going to be when t is equal to 4 seconds. 0 isn't really where it hit the ground, it's where it started. We have to look at the context of the word problem to find our one solution. Let's solve some more. So 0 equals 3x squared minus 27. I add 27 to both sides. Then divide by 3 and get 9 equals x squared. By taking the square root of both sides, I get x equals plus or minus the square root of 9, which gives us plus or minus 3 as our solutions. At x minus 15 squared equals 0, I'm going to take the square root of both sides first, and then we get the square root of 0 is just 0. Then we add 15 to the other side, and it's just 15 plus 0, or just x equals 15. Well, suddenly we went from having 2 solutions to this one having only 1. And the reason being, if we sketched this graph, if we instead of 0 wrote y equals x minus 15 squared, the vertex of this parabola is at the point 15, 0, and it opens up. And this parabola behaves in such a way that the vertex is on the x-axis, so it really only would have one solution. So when one solution comes up, on the x-axis. Down to our next one. First, I'm going to add 1 to both sides. Now I'm going to take the square root of both sides, and we have plus or minus the square root of 1. So x minus 5 equals plus or minus 1. We add 5 to both sides. 5 plus or minus 1 gives us 5 plus 1 and 5 minus 1. So x equals 6 and 4. Next problem has some more parts to it. Remember, we're kind of reversing order of operations. We're going to add or subtract first. So that's the 12. Now we're going to divide by negative 3, which negative 12 divided by negative 3 is a positive 4. We take the square root of both sides, which gives me plus or minus the square root of 4, or x plus 6 equals plus or minus 2. Last, we have negative 6 plus or minus 2. negative 6 plus 2 and negative 6 minus 2. Our two answers look like they're going to be negative 4 and negative 8. Now on the bottom left, I'm going to start with dividing both sides by 5, and it's still 0 equals x plus 4 quantity squared. Square root of both sides, square root of 0 is 0, no plus or minus there, so it's just x plus 4 equals 0, and we get negative 4 equals x. And again, this would be a parabola where it had a vertex on the x-axis, and it only gives us one solution. Last one here, let's move it up a little bit. I'm going to subtract 42 from both sides, move that over, and next we're going to divide by 6, so we get negative 7 equals x minus 8 squared. It's starting to look a little bit different than all the other ones we've had, because when I take the square root of both sides, I get plus or minus the square root of negative 7. We can't do that. That is a no real solution. We're just going to stop right there. If you end up with a negative inside the radical, for right now, later on in a few sections it won't quite be the case, but for right now we write no real solutions. What does that mean? Well, if I took my original function, which was right here, and again put a y instead at the beginning, this would be a parabola with its vertex at 8, 42, which is about right there, we'll say. Now we also know, because the a value is positive, it opens up. And that parabola does not hit the x-axis, which is why it doesn't have any real solutions. So anything with no real solutions isn't some like crazy parabola that jumps off the page. It just happens to be a parabola that doesn't hit the x-axis, which is a lot of parabolas we may come across. For right now, though, no real solution works.